Oh, yeah, it's work.
Okay, it's working now?
Yes. Yes.
Okay.
Hello, everyone. Sorry for this, some technical problems and that we a little delay. Yeah, so welcome all to Data Phoenix webinar. Today we will talk about generative AI application. We will talk about some architecture and some use cases, and we'll see the demos. With us, Tingy Lee, correct?
Yes.
Yeah, thank you. She is enterprise solution architect at AWS, and she will tell about more about generative AI application. Your questions you can ask on YouTube channel chat, and in the end we will answer for them. So for now, I will give the microphone to Tingy.
All right, thank you, Dmitry. So hello, everyone. Thank you for joining the session and thank you for your patience. Sorry, we were running into some technical issues. So I guess this webinar will be a bit exceeding our original ending time so that I can make sure that I cover everything. But if we don't have time for Q&A or anything, make sure to reach out to me later. We can have that, take it offline, like catch me later. So now I will just start sharing my screen. Okay. Give me a second. Sorry, I have to log out quickly and log in so that I can share my screen. Just give me a minute.
Okay.
Okay, so I hope now that you're seeing my slides. So as okay, perfect. So as we spoke before, I'm going to exceed some time to make sure that I cover everything because I really have a very long agenda. So are you seeing my presenter mode or?
Yeah, presenter.
Okay. Yeah, I don't know how to share. Let's do this. So now you're still seeing my presenter mode?
It's still the
is it the slides or the presentation?
Yeah, it's slides. It's presentation. It's not the slides.
Is it is it with notes or without notes?
It's still the application.
Yeah, I mean, is it with is it a correct window, right?
I think no, because it's
I'm choosing to share this window 1, but it doesn't work. Give me a second.
Oh, now it's good.
Oh, okay.
Yeah.
Perfect. All right. So let me close this. All right. So thank you for your attention again. So hello everyone. So welcome to the session. So of course, like the session will be recorded. So if you don't think it will exceed too much time, just feel free to log out, and then you can find it on YouTube later. So before we start, today we're going to talk about generative AI, and we're going to be focusing on generative AI application to go beyond chatbot and talking about some emerging patterns. So before we start, let's think about, like, with all these generative AI hypes, ChatGPT, all these fancy chatbot applications. So why do we need to care about, like, going beyond that? Isn't like this is already the greatest thing that will solve all the problems? So of course, the answer is no, because though chatbot is still one of the most common use cases that we encounter today, of course, ChatGPT is a great example. It's not a model, it's an application. So it takes the consumer world because it makes access to large language models so easy. But when we talk about, let's say, industry examples, as like my daily jobs, like I work with large enterprise customers, when it comes to different use cases across industries, it can be quite different, and it can grow to be really complicated because we're talking about things in production driving enterprise level business values. So you have to care about like security, performance, scalability, and all these different things. So it can become more and more crucial. So to realize this, we need to build generative AI applications. So this is why we care. So my name is Ting Yi. I work as an enterprise solutions architect at Amazon Web Services based out in Stockholm, Sweden. Prior to AWS, I have worked as a data and AI engineers and also software developer roles at Intel, Foxconn, and Huawei. So right now, I'm mainly working with large enterprise customers based out in Sweden from manufacturing and financial industries. So today I'm going to talk about, let's say, we're going to focus more on the use cases and the general patterns of the generative AI applications. So here is today's agenda. First of all, we're gonna set up some basic mindset, like what's the kind of the raising concerns, use cases, and patterns that we should consider when we start to build your generative AI applications for your business use cases. At the same time, we're gonna go through some limitations that are with LLMs by nature that needs to be overcome by building a generative AI application. And then we're going to cover the general architecture overview and some of these core components. And then we're going to work backwards from some of these sample use cases, and I'm going to show you a few demos. And then we're going to drill down into Q&A and conclusion part. So first of all, please notice that this session is a general overview. So I'm going to sort of bombard you with a lot of information. We don't really have time to dive deep into each of these components because the landscape is really expensive. But I will share with you some resources that you can dive deep into specific domains that you might be interested in. And also, I'm going to assume that you have the basic understanding of like the concepts from generative AI, like large language models, maybe Pinecone, or like vector database, like this kind of concepts. Yeah, so without further ado, let's jump into there. So as we spoke before, so generative AI applications, though foundation models are powerful, so when we say foundation models, we're not talking only about large language models because LLMs are just one type of foundation models that are focused on texts. So foundation models are, of course, at its core of a generative AI application, but still, it takes a village to build the whole application. For instance, as you can see from the picture here, at the top layer, this is the application layer or the front end. So this indicates how your customers will be interacting with your application, with your models, how they're going to consume the products. So for instance, you may have multiple different engagement resources or channels to interact with your customers. Not only just text, for instance, images or videos or different diverse set of formats, such as like emails, SMS, not only just Q&A or via chatbots. So this is something that you really need to think about, because with the thriving of generative AI, it can revolutionize a lot how we interact with these digital devices. Just like a decade ago, when, for instance, we have touch screen, we get rid of keyboards and everything on the phones, right? So generative AI will for sure bring the next level of revolutionize in of the front end part. And then on the other side, you have the tools. So this is everything that you need in addition to be able to create the foundation models. For example, your developer tools, your prompt tools that help you create the right prompts for different models, and data annotation, like how you're going to evaluate the model, the performance metrics, and also human in loops. I'm going to cover that a bit later. So actually, a lot of parts are quite similar with traditional machine learning applications, but on top of that, you're going to have something new for generative AI application uniquely. And of course, you have machine learning infrastructure at the bottom. So of course, like where's your MLOps? How are you going to make sure that you have all the tools that you need to guarantee that you follow this process of machine learning, like traditional machine learning practices, end to end, from data ingestion, from all the way to data consumption, feature engineering, etc., to make sure that in the middle, you have the necessary checkpoints to guarantee the quality of what you are going to generate. So these are all these components that we're going to look deeper later. So let's start with a simple example. So hallucination, I guess a lot of you must be very familiar with it. So essentially, this is a very simple example of hallucination. I'm sorry, is it like there's something in the screen? Okay. Dimitri, I'm just wondering if it's something in the screen popping out. Like, okay. Yes. Okay.
No,
Sorry.
I think it's your mouse.
Oh, okay. I'm just sorry. It's just from my side. It's popping out. Okay. So the quick example, for instance, let's assume this foundation model is ChatGPT. So it's already pre-trained on like Wikipedia and some web crawling, like all the data out there on the internet. So for instance, if you ask what foundation model is supported by Amazon Bedrock, so this is our newly announced service for large language, for foundation models. So it will tell you, okay, some like random thing like radio X FM, like it's mixed it up with some channels. Because like ChatGPT doesn't have the knowledge up until now, because up until like 2021, when the ending ends, right? So that's all the knowledge it will have. So that will create hallucination. So it can be due to different reasons, and also it can be different levels of hallucination as well, like low quality training data, out of date data, like maybe there's some factual errors, like low quality training data, or just lack of context, or basically the training data consists of some of this sarcasm, discrimination, or slang expressions that can create harmful content. So all of these are hallucinations. And in order to overcome hallucination, you need to customize your foundation model. Let's say there are several methods. Just a quick general overview is that the first one would be prompt-based learning, which is also what we usually call fine-tuning. So basically you have a small domain-specific labeled data set. So you don't have to relearn the whole weights, like the weights of the whole model, because that will be too time-consuming and cost-effective. You only need a small amount of data to do the fine-tuning on top of that for your model to make it adaptive on the additional data set. And then the second one will be domain adaptation. So this one will be more task heavy. because it will be like, okay, you're gonna adapt the knowledge from another domain. So you have actually go and relearn the whole model weights. And this is going to take some time and some money as well. And it's going to take a lot of work to get the data in such state. So you can measure the cost and to run the model to be able to pick it up from. And the last one is also the one that we're going to dive deep later, information retrieval, also commonly known as RAG, so retrieval augmented generation. So essentially for this, for the previous two methods, it requires some sort of training on your existing models. But for the new one, you don't necessarily change anything like on the model. Instead, you're providing additional context from your databases as prompts to provide this context to your foundation model so that they can generate the right answers that you want. So let's say a common question would be like, when should I fine tune? When should I train? When should I use RAG, right? Of course, let's assume like generally there aren't very many companies or like individuals that can really afford the price and time to train a large language models, because it can easily cost you millions and billions of dollars. So for fine tune and like RAG, essentially for fine tune, you don't fine tune a model to store facts. You fine tune a model to store new ideas. Like you change the mental models in the model for your domain. For instance, let's say if you use ChatGPT or like GPT-3 or GPT-4, let's say you are working in medical industries. And then if you are only just going to ask some basic questions, say, okay, check out this medical documents for me, like what's the relevant information? You use RAG, right? Because that's additional knowledge and facts. That's not like the mental model. But let's say if you want this chatbot to become some sort of a medical chatbot to kind of play this patient and doctor like role play, then you fine tune the LLMs using your domain specific data sets, like medical data sets, so that it can interact with your end users, the patients, in a way that is like a doctor. So it's a little bit different. At the same time, you don't fine tune an LLMs to change the style of answering. Instead, you can use something called instruction tuning, like reinforcement learning with human feedback, like either with it or without it, to change the style of answering. So you basically teach it, say, okay, this is the kind of prompt and completion that I would like to have. So you don't have to fine tune that. Instead, you just provide additional context for it, like specify it in your prompts. I mean, normally for these offerings from this giant techs from Microsoft or from OpenAI or from Google or from us, AWS, for those commercialized APIs, we always provide you with a way to fine tune your models. For instance, with Amazon Bedrock, you can easily fine tune using your own data set. At the same time, if you use some open source model, you would like to fine tune it yourself, you can use like LoRa, which is very popular low ranked adaptation. So it's one technique from parameter efficient fine tuning. So we're not going to cover this in details, but I will share some resources later if you're interested, like some example codes. Yes, so that's just one quick example. So now let's take a look at, so before we look at the architecture for the generative AI application, there are some limitations of large language models that we need to be aware, and then we can address them when we build the generative AI application. Of course, so here, all these limitations, they're not exhaustive. So it's just a few examples. There can be a lot more. Okay, so the first one is that, as we covered, like it's not easy to incorporate the latest data for specific data. For instance, like you ask this World Cup 2022 to ChatGPT, then it will not be able to answer you, right? So for instance, for Bain, it tried to resolve this kind of problem by using like browsing the internet, like you have a search engine to help it search the relevant information and then provide it back to the model and to the users. So this is one common one. And the second one is, so AI models are incredibly smart, but shockingly stupid. So for instance, like as the example shown here, let's say you ask it, okay, can I light up a fire in the forest? Or like, how can I steal something from the bank? Or like this kind of not moral question, because the AI models don't have the common morals, common senses with as humans. So it doesn't know, okay, this is a question maybe I should not answer. So it will just tell you how to do it. So our goal here is, of course, like we would like the models to be governed, to be controlled, so that it can tell, okay, this is not a moral question, and I should not provide the relevant answer. So tell something like on the right side, right? So for instance, we're going to cover some ways to do that, like constitutional AI, guardrails, etc. And the third one is that models work as black box, so it cannot access external systems. So it needs some engineering. Imagine LLMs or other foundation models. They're like a brain, like a human brain. Let's say if you ask them to do some really hard, like mathematical jobs, it will not be able to do that because it's a text model, it's a language model, right? So it needs to access additional tools like a calculator to be able to do that. For instance, I have a quick demo here. Let's say if you ask the ChatGPT to say, okay, make me this Mandelbrot plot. It is a very complicated plot. And then if you provide it with additional tools, for instance, a Wolfram, it will be able to provide you with this kind of diagram. And then if you ask it like a super hard question, normally like language model cannot do, they're very bad at mathematical questions. But if you provide them with the tools, it will think, okay, say, okay, it's time for me to use the calculator, and then it will be able to go to the calculator. So this is something that we can achieve by using, for instance, the orchestration tool like agents. This is one of my favorite features from LangChain. Okay, and the third one will be, okay, it doesn't have long-term memory. So out of box foundation models that don't have long-term memory. Like if you ask one question, what is Amazon Kendra? And then you just simply ask, what was the last question I asked? It doesn't know, right? So we need to have caches. So this is no difference with all the applications that you have. First of all, you need to have conversational memory so that it can maximum its performance. At the same time, completions. So for instance, you use these API-based generative AI services. You are charged based on the prompts that you are sending to it, based on like the tokens. At the same time, you are charged when it's sending back, so the completion. So if you keep on, like every time you ask the same question, you keep on hitting that API, you're going to be charged all the time, right? So that would be super expensive. So it's better, a good idea is just to store the completions in some caches. So if it's the same question, then it doesn't have to hit the API again. So it would just return that previous question to save cost. All right, so that's just 3 examples to show you like a few limitations that we have. And now I would like to switch to the architecture. Hopefully I can do that. Yes, okay, I have this. All right. So I hope now you are seeing my draw.io. So it's my architecture.
No.
Oh, okay. Let me reshare maybe. Okay. All right. So I hope now you're seeing my.
Yeah.
Yeah.
Okay. Yeah. For now, yeah.
All right. So maybe some of you have seen this because I posted it on LinkedIn before this session, and I received some really good feedbacks. So thanks for that. So as all the generative AI applications, you have front end, back end tools, as we saw at the very beginning, right? So let's start, just go through all the components very quickly. So first of all, you have front end. So when you build your applications, like for me, actually front end, although it's not really part of like language models or like generative AI domain, but from a business perspective or from a user endpoint or from a use case endpoint, it's really important that you think from how you would like to interact with the users first. What are the formats? What are the interaction? What are the engagement resources? And then you work backwards from there, and then you can route the correct data from the user correct request to your large language models. So this part is actually very important. So first of all, you have Chatbot. So for AWS, you have Amazon Lex, so which is an intelligent chatbot service for you to build this like back and forth conversational interface. At the same time, for instance, you can use Alexa, like this digital assistant, or maybe via SMS or email, like when you want to run some marketing campaign, or maybe it's a robot, or like website, or like different formats, image, video, audio. So these are kind of things that you really need to think about before you start to build it or decide which large language models you want to use. And of course, at the backend, you have the core, the foundation models. Either you can use open source one, where you are probably gonna download it from like Hugging Face, or like you directly use it hosted there, or you host it on AWS, like EC2 instances, or like container service like Fargate or ECS, or maybe you host it on like Amazon SageMaker, like as an endpoint. So those are for like the model that you have the artifacts with, or like you just want to host it somewhere, like have more flexibility and customization yourself. At the same time, you can do it with APIs, like all these proprietary models are offered via APIs. Amazon Bedrock, and of course, OpenAI like GPT-4, like all these APIs are examples of proprietary models. And for that, because most of them are serverless, so you don't have to care about the infrastructure, you just pay for the token, like the request. So you pay as a go, right? So you just pay for how much you request to it. And of course, like when it comes to machine learning infrastructure, because large language models requires a lot of compute. And we need to, especially when it comes to enterprise grade applications, you need to understand, okay, how much user requests I'm handling today, especially when you are deploying the models yourself. So you need infrastructure that are scalable enough, reliable enough, secure enough to handle these requests to support your large language models. And at the same time, the cache, as we said before, so all these caches you can use like Redis, SQLite. And because of this hype, because of this emerging of Gen AI, actually more and more of these database of vendors, or like different these cache vendors, including some orchestration tools, the community is emerging. So they're adding a lot of out-of-box integration with like other like APIs, or for instance, Amazon Bedrock is collaborating with like some other vendors so that it can have a better integration with like different databases as caches. And at the same time, as we said before, like MLOps, so machine learning operations. So because we're talking about large language models or generative AI at scale, so the operational side and productionization side is definitely like something that we shouldn't ignore. When you have like let's say when you have a lot of models in production, you have to version control them, you have to test them, you have big teams, like how they collaborate with each other, data scientists all the way to machine learning engineer to DevOps teams. So those are the operational practices that we need to know. Honestly, not only for, let's say, FM ops, like MLOps for generative AI, not only for FM ops, just for machine learning or MLOps. It's like something that we've been talking about for such a long time, but still there is no, let's say, golden standard for MLOps per se, because it should be really adapted to your organization, your enterprises. So we're not going to talk about FM ops or monitoring today, but my colleagues have done an amazing videos diving deep on this. So I'm gonna link it as a resource later as well, but this is something that you should keep in mind. And then orchestration. So this is very important part. but it's really getting mature. Like I'm really amazed by how mature these tools are. For instance, LangChain, Llama Index, and also some other like open source ones. Like the community is emerging, and they have a lot of functionalities, like to make building such applications so easy. So we're going to cover a few examples later. But this is at its core. So it really brings front end, back end, and all the tools together. And at the same time, on the side, we have tools. So prompt tools, and also here, the embedding models and vector database. So this is the one that you need to implement RAG approach. This we're going to dive deep later. So some common tools like Amazon Kendra, Amazon OpenSearch, Fice, Pinecone, like all these kind of vector databases that you can use out in the market. So I'm sure there's going to be more coming up. And also my colleague have done a dive deep blog on this so that you can see, okay, which one you should choose for. So I'm going to link it as a resource later as well. And then the alignment. So alignment is important, as we spoke before, because it's part of the security. Sometimes you cannot overcome all the LLMs limitations. So there will be alignment inside the model and around the model. So we call inner alignment and outer alignment. And there are some common tools like NeMo guardrails by NVIDIA, and constitutional chain. So it's one type of chain from LangChain, the orchestration tool, and Robust and some other tools. So just to help you secure, to make the response less harmful. And of course, there's some other more. I'm not going to spend too much time on this, but this is just for you to know, okay, these are all the components that we have when building generative AI applications. And one thing very quickly that I got some comments when I share this architecture on LinkedIn about, okay, where's the data? That is a very, very valid question, because you have to understand that the differentiator is never the technology, it's your data. Because let's say all these foundation models, they're out in the market. Let's say your competitors, they will have access to those foundation models as well. So it's the same, but your data, so you need to so for these foundation models to really be useful to your organizations, you need to enable them to access the right data sources, because your data is your differentiator, right? The reason I didn't put data in this architecture is that it's so flexible. You can have it a bit like everywhere, depending on your use cases. It can be streaming, it can be bashing, it can be stored somewhere, right? So I just place it somewhere just for your reference. For instance, in between the front end and back end, you can have data streaming here, right? For instance, later on, we're going to talk about one use case talking about live sports streaming. And in that case, your user request is coming as streaming data all the way to your large language models. So that's streaming cases. But at the same time, you probably need to process your data and then store it somewhere in your data storage or your data lake, maybe Amazon S3. And then at some point, you use them to run some inference. So there can be different use cases. At the same time, for RAG, RAG is the purpose for a RAG approach is to provide additional context to your large language models. And sometimes you need them to have real-time data as well. For instance, e-commerce website. Let's say when you provide additional data set, you want it to be the most up-to-date, right? For instance, the item catalog, it has to be always the most up-to-date, or maybe user profile, the click stream, it has to be always the most up-to-date. And then you can use data streaming to provide real-time, most up-to-date data to your vector database as well. Or it can be stored as like storage in databases or data lake. So it can be very flexible, but data is something that you should not forget. So let me just quickly stop sharing, and I'm going to switch back to slides. Okay, So now we're back to slides. I'm just gonna, oops, I can't, okay. Yes, so the next part we're going to talk about, so from what you saw, all the components that you saw from that architecture pattern, we're going to go through very quickly a few key ones. So the first one.
Sorry, I think you share still drive IO.
Your not
Yeah,
slide.
No, I don't see the slides.
Okay, let me try again. Okay, so how about now?
Yeah.
All right, perfect. So now let's start with foundation models and machine learning infrastructure, right? So I'm going to go through AWS machine learning stack very quickly, so given our time. So maybe some of you are familiar with AWS AI/ML stack. Essentially, when we design the stack, we have like from top to bottom, a different level of machine learning offerings. So let's say if you are really experienced, so you have like down here, the infrastructure, like you get access to the container, you get access to the different frameworks, and of course, hardwares. So you customize everything you have yourself. You run the notebook, and then you host it on some EC2 instances. And then in the middle, we have Amazon SageMaker. So this is like an end-to-end machine learning platform offering like different selections, different features. It's a collection of features for you to use for like you can spend, if you're a data scientist or machine learning engineer, you can spend the whole lifetime here. And on the top layer, they are API-based services. So as you can see here, they are purpose-built. They're focusing on specific tasks, for instance, personalization, search, conversational AI, or like prediction, forecasting, this kind of thing. And for generative AI offerings, we also offer you like several ones. On the top is Amazon Bedrock. So it's an API services. So it gives you access to a range of foundation models, including the ones that are proprietary to Amazon, to AWS, Amazon Titan. And other than that, you have access to some state-of-art generative AI companies like Anthropic, Stability AI, and also AI21 Lab and Cohere, etc. And there are some like for specific, there are some applications, for instance, like Code Whisperer, they are for coding companion. And also we have Jumpstart. So Jumpstart, it offers you a range of open source models, for instance, from Hugging Face, at the same time, some proprietary models. So you can host it on Amazon SageMaker as an endpoint. And down here, you have AWS Inferentia and AWS Trainia, which is the AWS designed machine learning inference and training chips. So it can provide you with up to 50% price performance compared with comparable EC2 instances with GPUs, etc. And based on my personal experience, they don't support all models like GPU, so they're not that flexible, but for certain types of models, they are super performant. And also it can save you a lot of cost. But given time limit, I'm going to just switch very quickly through here. Yeah, so these are just some introduction on our services and also the models that are provided, the foundation models provided from SageMaker, Jumpstart, or Amazon Bedrock. And of course, our infrastructure. So let's directly jump to RAG, so retrieval augmented generation. So as the name suggests, so retrieval and generation, right? So retrieval means to get the information. So for getting the information, you need to store your additional information in some sort of storage. Knowledge base, like as we covered, OpenSearch or Kendra, you can search it in databases. So for instance, more and more these databases are supporting like vector like vector or like this kind of ROG approach. For instance, RDS, you can use PG vector directly with this. So it has this support for this plugin. And of course, maybe you can use search engines out in the internet. And for generation, you use large, for generation, you use, for instance, you have the context and then you provide it with your foundation models, right? So the foundation models, based on the context you provide, will generate the response to your end users. So one example architecture would be like this. So your user asks certain questions, and then it can get additional context from the knowledge base and then send it together to the foundation models, and then you get the answer. And then when you prepare your foundation knowledge base, you use something like an embedding model to convert text, images, videos, audios, whatever, as vectors. And then you store them using like vector databases. So here I'm only saying, okay, it's document. So document store is focused on text, but in fact, you can of course do vector embeddings for images, audios as well. And to mention it specifically, with Amazon Kendra, you don't have to have it separated. For instance, for Amazon OpenSearch, you need to have an embedding models, maybe Amazon Titan embeddings or GPT-6. This common embedding models, and then together use it together with Amazon OpenSearch. But with Amazon Kendra, because it is an intelligent enterprise document search engine, so it already help you kind of do all these things. So it's like one thing replace these two components. And then for Chatbot, it's similar. Like we have, for instance, the additional context, like here. So for Chatbot, usually you have to have a chat history, right? So this is the caches you have. So this is essentially the workflow. Like every time you ask a question, they're gonna search the chat history first. And if there's no answer, if there's answer, it will send it back. If there's no answer, it will get the additional context and then send to the LLMs and then get the answer. So that's the flow here. And now if we jump to the orchestration tool, and here we're only going to cover LangChain because it's by far the most popular. So there's the idea of chain of thoughts. So it's a prompting techniques used to encourage the model to generate a series of intermediate reasoning steps. So LangChain, as the name, so it's like a chain, it's based on chains, right? So it's a framework for orchestrating and developing applications powered by large language models. So as you can see on the picture, so it brings everything together. It's an intermediate orchestration tools. For instance, there's embedding models, there's vector database, there's additional plugins or tools. It brings everything together and you implement your business logics using LangChain. So you have like a tool hosted somewhere. So that's the core of your application. And then within the business logic, somewhere you call the large language models, right? So this is the framework. So there are the modules, like 6 modules within LangChain are the most important. It's likely to grow more, but right now it's the 6 of them. So you have models, of course, large language models. So LangChain is well integrated with a lot of large language models. I would say most of them, most of the popular ones that out there in the market, like OpenAI or Hugging Face or AWS, like all these integration is very smoothly. You have the APIs already there in the framework. And you have prompts. So there's built-in template for LLM prompts, example, output, parser, etc. And of course, you have indexes. So it's focusing on optimizing the structure of documents for interacting with LLMs. So it provides utility functions for working with documents, different types of indexes, and examples of using indexes in chains as well. And of course, chains. So a chain is like a sequence to achieve a complex applications. So you can chain a few operations together. You can chain a few LLMs together to complete a single task. For instance, you have to get an answer of a first question, and then you use the answer of the first question to as prompts to the second large language models. So you can chain them together like a hard-coded sequence of actions. And also you have memory. So LangChain is well integrated with a lot of these databases like Redis, SQLite, these kind of databases to use as caches. An agent, so this is, as I said, it's my favorite feature. So it helps you to implement the logic of your application. At the same time, it utilizes large language models to decide what should be the next step to take action. So the difference between agents and chains are like, chains are hard-coded, so it's already predefined. You cannot change it. So it will be a series of actions that are going to be performed. But for agents, it's like, okay, for instance, agents get access to a bunch of tools, and based on the user's question, it will say, okay, it's time to use a calculator. It's time to use something. So it's more intelligent. So it can tell you which tools to use, what should be the next step to take. We're gonna take a look at one example. So without LangChain, so you ask something like, how old is Leo Messi's girlfriend after 10 years? Well, it looks pretty dumb. But with LangChain, for instance, you use agent, and then you provide it with some tools like the mathematical tools, and then it will be able to say, okay, this is time to use these tools to search what age is Leo Messi's girlfriend and to do the calculation, and then it will be able to provide you with the answer. So now let's see an example. For instance, I'm a solutions architect. So my job is going to be taken by AI soon. Let's build a solutions architect agent. For instance, the agent needs to perform two tasks. So based on the user's question, it should either implement a code generation or a diagram generation. Okay, I guess I have to stop sharing again. I would say maybe given time limits, let's skip this part. So we have a blog post that is going to tell you how to build this. So that's, for instance, the user asks, say, okay, build me a diagram to connect Amazon S3 to Lambda, and then we'll produce you with a diagram. On the other hand, if you say, okay, write me a code snippet to upload S3 to upload some file to S3, it will generate you a code snippet. So the LangChain agent is able to tell you, okay, which tools I should use. I was planning to show you some demo, but I think its time is a bit limited. But I will share with you the link. So because we have some other demos to cover. Yes, please.
Yeah, we can try to show the demo.
Sure. Okay, I will just switch then. Let me try sharing this. Okay, so now you're supposed to see my Visual Studio, VS Studio. Yeah. Okay, perfect. So this is a sample notebooks. It's not yet an application because it's the purpose just to show you, okay, how you use LangChain agent. Of course, you have some prerequisites like LangChain, just import these libraries. And here I'm using some models directly from Hugging Face. So it's already hosted on Hugging Face. So I'm having my Hugging Face key. And here, this is the prompts, right? So this is my SA prompts. So I will say, okay, I'm an expert SA. My role is doing some of these jobs. And my task is to help customers understand something, write some codes, etc. So these are a few tasks I have. And then I need to define tools. So this one I already deleted, but so let's skip this one. For instance, the first tool that I need to use is code generation tool. So with LangChain agent, of course, as you see before, you can use the existing tools, for instance, the LLM math. So these are some of these built-in tools that you can directly call from LangChain. At the same time, to be able to have more flexibility, you can define your own functions, right? How you would like this tool to perform, like what actions you want. So here, I'm just having this define this function called code generation tools. So essentially, it just generate codes, right? So the API here, so this is my LLM endpoint. And here I have call the endpoint. So I will generate the text, and then, yeah, basically I will just have the code and return it. So this is my function. So this is just one, this is just security function. And here, the second function, that second tool that I define is diagram creation tool. So here I'm using a library called diagram. So it can help you using code, writing code to generate the picture of a AWS architecture. So here, same thing. I have called the LLMs here. And I have defined like some sort of conditions just to convert the prompts into the correct format and then send it to the LLMs. And then it can return this image to me. So these are the two functions, like two tools that I want this LLMs to have. So for instance, let me see, I think I could be able to just run it directly. Yes, so here, of course, like I write a query, like a diagram that shows an S3 bucket connect to a Lambda function. So, okay, so this is just for testing. Let me switch down here. Yes, so here, now we have two functions of tools. So here you see I'm calling an agent. So it's a Hugging Face agent. And then here's my LLMs. And here's my prompt template you see before. And here's my additional tools. So code generation and diagram generation. So these are a few default tools from Hugging Face agent. So I'm just removing it so that it doesn't mix them together. So now it only has access to these two tools. And now when I run this agent, yeah, so it will be, so it will go through, of course, this is not perfect because it will go through some of these thinking processes. It will say, okay, I will use the following tools, okay, code generated by this, and then the results. So here the arrow is only because of the format of the image. So it doesn't show like the RGB, some channels were missing, but it doesn't stop us from seeing the results. So here you can see the results. And on the other hand, if I say, okay, agent run the function in Python, yeah, and then if I run it, it will say, okay, I'm gonna use this tool, and then it will provide me with this snippet. So you see like the same agent will be able to tell different tools to use. Okay, so I'm gonna switch back. It's just a very quick demo to show you the power of LangChain. Okay, so now let's continue. So here is an extreme case. This is, let's say, if you want to build a financial agent bot that can help the customers with a series of financial tasks, like, for instance, prepare unstructured text data, processing audio data, like, for instance, the customer uploads some documents, you'll be able to tell them, okay, this should be your right action. Maybe this should be the compliance. You are not compliance, you should check. Like all these series of financial tasks, it can be an ocean of them, right? And of course, the request can be in different formats, like unstructured or audio or text or images, all these things. Imagine you want to build this all-rounder kind of a financial agent. And then you need to have like text processing, sentiment analysis, creating visuals, customer intelligence search, computation, audio processing, all these things. And here is where agent will shine, right? Just to give you an example architecture. For instance, you have these different formats coming in. You store them in Amazon S3. Of course, you can use Athena to run some analytics on it. And then maybe after some point, you would like to do all these tasks depending on how the user asks it. So you see all these different tasks, like all these different tools, like from these are all the AWS AI services for different purpose-built tasks. For instance, for comprehend, it's for analyzing sentiment analysis or extract keywords, etc. So you have a bunch of APIs. So you all define them as different tools, and then you put them as agent, right? And then when the user asks corresponding question, you have your LangChain agent to call this corresponding tools for you. At the same time, you can have memory caches using DynamoDB, and you have your foundation models behind the scene. Yeah, so just to show you an extreme example, how useful agent can be. All right, so let's jump to alignment and safety quickly. So this part, I'm not going to spend too much time because as we spoke before, this is something that you need to, let's say, consider, let's say, maybe your compliance, your regulatory requirements from your companies. And also part of it, especially the inner alignment. The inner alignment really relies on research side, like it's part of the training processes. So sometimes we don't really need that. We don't really have occasions to use them, but it's good to know them. So the AI alignment problem is a challenge of defining the scope and limitations of an AI's response to guide users to answer without violating moral, ethical, and legal standards. For instance, Instruct GPT. I think this one, maybe some of you might know. So Instruct GPT is actually kind of, let's say, fine-tuned based on the original GPT-3. And it removes the harmful responses from GPT-3 because GPT-3 is not really well aligned. So this is one example. So let's say, for instance, jailbreak. So even if you have certain guardrails for your large language models, let's say, for instance, you say, okay, make me a list of websites where I can download pirated movies. It will tell you, okay, no, I can't tell you because it's not legal. But you can somehow manipulate it to have it jailbreak so that you say, okay, to make sure I don't visit them. All right, then it tells you, right? So this is like a typical example of jailbreak. So this will be one example from AI alignment problem. So this, like, there's a lot of researches going on in there. So as we spoke before, there's inner alignment and outer alignment. So one example is for inner alignment is reinforcement learning with human feedbacks. So this has been so popular since the release of ChatGPT. So it's like a machine learning technique where the model's training signal uses human evaluations of the model's output rather than the labeled data or a ground truth rewards signal. So essentially, okay, let me have a look. Oh, yes. So essentially, it's like human in loop, right? So you're using human to run reinforcement learning and fine-tuning on top of your pre-trained LLM, which is pre-trained based on low quality data, so that it kind of tells it, okay, this is right, this is wrong, like what should be the constitution or guardrails around it, and then it gets better. So it's part of the training processes. So ChatGPT is trained using these processes. There's a whole paper about it. So I'm not going to dive deep here, but if you're interested, you can search the paper on this. But as I said, like normally you won't really need this, right? But of course, for fine tuning, you can have human in loop, but not really from scratch. And the second one is constitutional AI. So this is created by Anthropic. So Anthropic is a group of people who originally left OpenAI after the GPT-3 models came out because they want to focus more on safety side. So the idea is like they want to build the model with safety. So they want to focus on that. So this is a very interesting way that they create. So instead of, it's a little bit similar to the previous approach, but instead of having human feedbacks, they're having machines like models as feedbacks to provide the feedbacks. So essentially, like the first part is like you generate the original harmful responses, and then you critique on it. For instance, you say, okay, can I hack my neighbor's Wi-Fi? And then it will tell you how to hack your neighbor's Wi-Fi, and then it will criticize on it. For instance, say, okay, this is not moral, you shouldn't do this. And then it will provide this critic as part of the context, and then resend it to the model and say, okay, can you provide me with a revision? And then the model will provide you with a revision, say, okay, this is not moral, we shouldn't do that. I'm not going to provide you with the guidance. So you're going to have several pairs of these kind of critics revisions, and then you use them as the to fine tune your original harmful models. And then you use the outputs from that fine-tuned models to do another round of reinforcement learning. So it's pretty complex there, but eventually you will be able to have a model that is under correct constitutions and governance with the correct like the level of constitution that you're aiming for. So this is also sort of part of the training processes. And the last one would be more relevant to us. So the guardrails. So this is the outer alignment. So the very simple ideas actually. So for the guardrails, like no matter what LLMs are producing, I'm gonna have a guardrails in between the users and the LLMs. So I'm gonna say, okay, for instance, if the user asks some political questions, but I don't want my LLMs to provide that content, the guardrails will be able to detect that. And then whatever the response is coming from LLMs, say, okay, it might provide you with some political content, comments on some certain politician. And then even though there's response coming here, the guardrails will say, okay, this is not right. I'm gonna provide you with another answer, which is like, okay, sorry, I cannot do that. So this is outer alignment. So this is more relevant for building an application on top of LLMs. So NeMo guardrails from NVIDIA is one example. And of course, a constitutional chain. So it's from line chain. So it's one type of chain that you can also look up if you want to do that. Okay, so as the, just very quickly on the security point, so responsible AI is an emerging topic as well. So all these model vendors, because it's a community, we're part of the community. So because it's driving so hard, it's a technology that has like really taken the world by storm. Actually, the regulations can't really catch up with the speed of this emerging of technologies. But we are seeing like more and more of this responsibility from different model vendors or generative AI companies. And of course, from EU side, we have like EU AI Act to try to regulate the industries a little bit. So it's catching up a little bit, but it's the whole community's responsibility to make sure that it's secure and in control. All right, now we jump to the interesting part, the use cases and demo. As I said, I'm going to work backwards from business use cases. So maybe some of you read the news. So the opportunities, the potential for generative AI is incredibly exciting. So it's around forecasted $7 trillion global GDP increase over the next 10 years. So you can apply generative AI in every business units, all lines of businesses, all different use cases in your organization. Like engineering, marketing, sales, finance, customer service, etc., to really just change your customer experience, to optimize that processes and drive the innovation. So there's a tons of opportunity there. So here's the example. So here's one of our customer, NeuroLove. So they are an AI art generation company. So they're using AWS to develop generative AI tools to generate art for content creation, enhancement, synthesizing, etc. So they have some videos out there, dive deep on their use cases. So if you're interested, make sure you check it out. So there can be tons of use cases, right? So here at the end of this presentation, I'm just going to provide you with like 2 of them to just give you an idea, maybe 2 or 3. So we can see some similar patterns so far, right, from what we covered before. Like for text generation or chatbot, you normally need RAG, right, for summarization as well. For image, maybe you need to focus on the front end, you use different models, etc. So let's say, first example, live sports commentary. So this live sports experience are really important because they're challenging because they're live streaming. So it requires like you cannot go wrong because it's living. It's like you have thousands or millions of thousands of audiences out there. So, but at the same time, people are asking for better experience, right? They want engagement. The audience want engagement. We want to kind of comments in real time, like these kind of things. So this creates new opportunities in the sports industry to come up with creative and interactive fan engagement strategies to gain a competitive advantage. For instance, you can showcase the most important moments in the game through in the game, like for instance, tweeting on a live broadcast to invoke a fan engagement. For instance, when somebody just aim at the court, and then it will be some live tweeting, and then all these fans can be commenting down there, something like that. So let's take a look. So one quick simple example, because it's live streaming, so you're gonna need some streaming service. For instance, KDS, a Kinesis data stream, or you can use Kafka or Flink, or these are the different technologies. And then you define your application hosted on AWS Lambda. For instance, you have LangChain framework there. And then behind the scene, you can use Amazon Bedrock. So here we can use Jurassic 2 Ultra, like one of this model available out there. And then it will be able to, let's say, it will transform the real-time telemetry data, for instance, the score, to the LangChain, and then the large language model will be able to transform the telemetry data into the corresponding tweets or like comments or whatever, like in the human language, right? And then it will stream it back to your application and then to your global users. So it's very simple example. So let me play this demo. Just trying to see. Okay. Quickly. So, let's see. All right, it's working. So this is the one dashboard of example. Let's say you have okay, so this is real-time telemetry, so like the score. And then whenever you have a new score coming up, they will trigger the large language models, and then it transforms the real-time score into like some real-time tweets. And then you can have, because it's language model, so you can choose to have like different style, like tweet style or poetic, like it's all different languages. So that's one use case that you can do from the previous architecture. Okay, so now let's move on. Because if you still remember, so the topic of the main focus of today's topic is go beyond chatbot. So it's not just about text, right? So it's also about images and videos and more. Let's say if it's text, one of the most applicable model would be Stable Diffusion. For instance, you can use it for text to image transformation or image to image transformation. So I have also recorded a demo here. Let's see. So for instance, for text to image, I can input some prompt. So let's say, for instance, I have some out-of-box one. I just use a simple one, young pretty sunglasses. And then I choose the style to be cinematic. Okay, then I generate it. It will give me something like that. So not bad, right? And then if I use image to image, and then I can turn on the camera or upload my image. So here I'm just turning it up. So that's me. So I'm going to take a picture. Yes. And here I can choose to have some like prompts, say, okay, what kind of style I want, and also choose like a theme, right? So I choose 3D model, and it will give me an image like that. Well, not so good, but still I will take that. Okay, and the last one that I have, oh yeah, I think, yeah, I was not really happy about it, so I rerun it once. Okay, so the last one would be like masking. For instance, I take another picture. And then I can mask, for instance, like those, for instance, semantic segmentation parts, like I can mask parts of it, like these are the pixels, like for instance, my hair, the region of my hair. So I mark these segments. Yes. All right. And then I say replace the hair with blonde. And then I choose comic book. And then when I generate the image, it will give me something like that. Not so good, but because it's not really productionized, but just to show you like the use case. So this could be, let's say, useful for like gaming or esports, like when you need to have an avatar personalized. So this could be very interesting use case. And another use case that I have is stable diffusion modernization. I haven't continue. Yeah, this one. This is based on one of our blog posts. So if you want to replicate this, you can follow that blog post and then you will be able to build this application yourself. So here, this is like, okay, for instance, I have several prompts that I think that are toxic or harmful. For instance, when it comes to like nudity or maybe some other like sexual content, like I don't want that. And then let's say if I say a lady in swimming wear on the beach, and then it will mark it. It will show me the picture, but it will mark it, like moderate it to warn me. And then if I want to show it, I can still show it, right? So the architecture for this one would be like, okay, you're hosting your application still on Lambda, and then you are expose it via an API gateway. And then behind the scene, you have stable diffusion, right? So when you have the request coming in, the Lambda function is doing three things. So first of all, it will trigger Amazon Comprehend customize a custom classifier. So it's a built-in classifier that you can use to, for instance, classify your images into, okay, toxic or non-toxic or multiple classes. And then it will get it back, say, okay, is it toxic? Let's say if it's toxic, at the same time, it will call stable diffusion. So you will still get the image back, no matter it's toxic or not. And then at the same time, it will trigger this recognition moderation detect API. So it's also an API, like a feature offered directly from Amazon Recognition. So you will also tell you, okay, should I moderate it or not? So based on the output from Comprehend and the output from the image, if it's say, okay, it's toxic, I should moderate it. And then when it comes back, it will send you the generated picture, at the same time, moderate it, and then show you the warning. So that's the logic behind this application. Okay, so that is all the use cases and demos that I want to just showcase. But of course, there's tons of them, right? And the presentation covers a lot of aspects. It can be very scattered, but I hope I still managed to kind of have a story in like chaining them up. But anyway, the key takeaways would be, first of all, you have to be aware like large language models have their limitations, and it takes some effort to build the application. And you need to have the purpose-built, scalable, reliable infrastructure to host the applications. And fourth is work backwards from your use cases, the front end, and then to your models. And of course, make sure that you have security in place. Okay, so thank you very much for your attention. So I guess we're over a lot of time. So again, it's a great pleasure to present in front of you. So make sure that you follow or connect with me on LinkedIn, and let me know if you would like to talk about generative AI or some other things in details. And if you have any questions, feel free to ask now, and I will make sure to share some resources on LinkedIn later. Thank you.
Yeah, we have one question. I think we will answer for it, and then we will answer for all questions if you will have in our Slack channel, or you can write directly and answer. For the knowledge base, how you keep all the saved data, which is already in vector store, indexed, and when you have new data, how the mechanism will be?
Yes. So of course, it depends a bit on your what kind of technology you use, right? Let's say if you use Amazon Kendra and you already have the indexes, so you will be able to, let's say you have let's say the data stored in S3 or some databases, and then when you have additional data coming in, Amazon Kendra you can have a scheduler say, okay, automatically detect the new data, and then it will generate the indexes like automatically when it comes in. So that's one way. But let's say if you're using embedding model plus some other vector databases, normally when you add new data there, you need to run through the embeddings and then put it inside the vector database, right? So there will be some operational overhead there. Maybe I'm not 100% sure, but maybe you need to kind of rerun for some of these databases, like rerun the indexes on the new data or on the whole data. I hope that answers partially.
I hope, yeah. Good. So thank you again for your presentation, for your overview and interesting demos. Also, I really like the demo for solution architects. I hope I will test it as also as DevOps architect. Yeah, thank you for all who was with us, and see you on the next webinars.
Okay, thank you. See you.